All right, so we just finished up the laser main sim. Now let's work on the actual main particle sim, the thing that's gonna drive the rigids and the smoke and, well, and particles themselves. So let's go back to the main object area and plop down a particle main sim, and kind of following our design here, we'll make that purple, and let's dive in. So our particle explosions are going to be based off of where the lasers hit the ground. So we just did in our previous simulation thing here, we have the stopped thing. So let's review that. So there they are coming in. Now we're not going to want to, we don't need to know all of the locations, but we're going to want to know which one just blew up. So we put our blast down, coincidentally enough, and we'll go to just hit and say delete non-selected, so we get those isolated. So now you can see every 4 frames they pop up. So if you get a frame where you don't see one, just move to the nearest one where you see it. So here's frame 62 where we got one there. So we could just say like ISO current hit, something like that. So from this we're gonna build up a geometric explosion using a sphere. And this is going to be a sphere that has like a whole bunch of points on it. So something like 31, 32, who knows? Whole bunch of points, 9,000, and we're going to give some kind of displacement to it to give it an explosive look. So here's it is using a mountain, and mountain's fine, but it only gives you so much control. This is going to be the main part of the lesson here where we're able to really art direct what the explosion looks like. And that is what we're going to do. We're literally going to design the explosion right now. And you'll see what I mean. We'll do it in a point VOP to displace the points exactly how we want it. So there it is. Every frame, we're going to get our explosion sphere there. And it's red right now, which is reminding me that these attributes, including the red vector there, is being copied over. I don't really want anything to get copied over except for V. I want to know the velocity, as you can see, the incoming velocity. And remember that velocity is shown as a trail on this, as opposed to normals, which point outwards like that. These are the only bits of information that I really need. And I'm actually going to drop down a normal SOP here. I don't really need this. As you just saw, Houdini will kind of derive its own normals on the fly, but just for the sake of completeness, I'm going to change this normal things to points. And now we have actual point normals on there as opposed to the derived vertex normals that you see here. We've got point normals and we've got velocity vectors. Cool. So there's our sphere. It's kind of big right now because this is going to be what we're going to build is the surface that the points are going to fly out from. We're going to make a particle simulation right after this. We're going to design our velocities, and then the points are going to spawn on the surface and fly out. So anyway, this is way too big. We don't need this to be so crazy. So I'm just going to bring this all the way down to something really, I only want to see this big. Let's make it like that. No, that's too small. Maybe something like that. So we can obviously always change that later, but that's pretty good. We still have our normals on it, and that's good enough for me. So now, the main event. Point VOP. I like to use the VOPs instead of the wrangles for this because when dealing with like the noise VOPs, they just have so many parameters on them already. It's just nice to be able to drop down a turbulence noise and then boom, it's all there for you. In any case, we're using a point VOP here, and we're going to start to design ways to make these velocities look cool. So the usual thing, as you might be used to by now, is you take the normal on a surface and you multiply it by some number that varies over the sphere to get like a kind of jagged looking surface. So we'll start by doing that. And that is ultimately the main engine that's going to drive this, where we take the normal that's pointing away from the surface, we're going to multiply it by some number that varies. So the noise, of course, will do that. We'll keep it with alligator noise, that's fine. We'll keep it with the 1D here. That just means it's a scalar value that we'll be able to multiply by this vector to change the length of the vector. And then we're going to add that new vector, that new offset, displacement if you will, from the surface. Add that to the existing position, and now you have a displacement away from the surface. And we can see that here. Now, so it just got big. Got bigger, it's kind of lumpy and weird. You know, the usual stuff applies. With the higher frequency I make this, the more jagged it will look. And this is the kind of stuff that we're gonna play with now. I also want to take a moment to say, because this is gonna get kind of complicated pretty fast, I'm gonna call this the main multiply. And I'm gonna call this the displace from surface, because this is gonna get it's gonna get crazy. And for some reason in my head I see multiplies as red and displacements as green. So let's just, you can color it that or do whatever you want. At the same time, ultimately we're going to want to spawn our particles. Once this is all done, we're still going to want to spawn our particles from the regular sphere. I only want to see this surface displacement to kind of get a sense of the shape of our simulation. But really, this main multiply here is actually calculating the velocity that we're going to use. So you see if I click velocity, I don't really see anything, and that's because it points inwards. See all these little lines pointing inwards? So because of that, I also like to plug it into the normal, and that way I end up viewing the velocity actually with the normal thing, which points out. It's the same vector, it's just that Houdini will have the normals point outwards and the velocity as a trail points inwards. So just a little thing to keep in mind. So there you have it. So that's this right here is the main engine in a sense. Again, noising up the normals, adding them on, and then viewing it with this, but ultimately we're going to subtract that back out again right afterwards. In fact, I'll do that now. So right after our design velocity, let's drop down a little wrangle that just immediately takes the velocity right back out again. So you can see we're right back to the original sphere that we had. We get to see the shape of the explosion here, but ultimately it's actually stored as the vectors here. So I hope that makes sense. Revert to original. Great.